all. This is Mr. G, and this is our warm-up for today's lesson. So pause the video right here, give this problem a shot, come back when you think you have an answer. We're going over in 3, 2, 1, let's go. It says find the following information for the function f of x equals 2/3 x squared plus 8x minus 5. Now, it does not say graph, which is going to save us a little bit of time. So we've got to find the vertex, axis of symmetry, blah, 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 all the rest of the stuff. Let's start with the vertex. We see this is written in standard form. Hopefully remember, standard form. So that means we need the formula negative b over 2a. Absolutely need to have that memorized, negative b over 2a. So let's see. That's our a, b, and c value right there. A is 2/3, b is 8, and c is negative 5. And we can use that to just plug in negative b over 2a. So negative b becomes negative 8 divided by, let's see, 2a becomes 2 times 2/3 times 2/3. And let's see, let's leave the negative 8 alone. Let's treat that like a 2 over 1. 2 times 2, well, 2 times 2 is 4. Over 1 times 3 is 3. So it's like a negative 8 divided by a fraction. So let's multiply, let's sort of section that off. Let's multiply by the reciprocal. So it's negative 8 times 3 over 4. Make that an 8 over 1. We can cross cancel the negative 8 and the 4. The 4 turns into a 1. The 8 turns into a 2. And negative 2 times 3, we get negative 6. Now, we have to keep in mind, what does this number represent? Negative b over 2a, that formula always gives us the x value of the vertex. That's why we have to start with it. In standard form, we start with negative b over 2a because that gives us the first step toward the vertex. Okay. Now it's just a matter of how do we find the y value of the vertex? Well, hopefully we know. Anytime we have an x, we can plug that x in and find a corresponding y value. So let's plug that in to our original function f of x. So I can write this as f of negative 6, the x value we're plugging in, equals 2/3 times negative 6 squared. We're running out of space there. Let's slide this over. That should be good, hopefully. Where was I? Plus 8 times negative 6 minus 5. Then we just do a little simplifying here. So let's see, negative 6 squared, that's 36. So it's 2 over 3 times 36. You can use a calculator for this if you want to do it a little bit faster. Minus 48 minus 5. Scroll down a little bit, keep my face out of the way. Let's see, I can cross cancel there. The 3 turns into a 1, the 36 turns into a 12. So we get 24 minus 48 minus 5. 24 minus 48 is negative 24. Take away 5. Wait a minute. Yeah, so it's negative 24 minus 5, and we get negative 29. Yeah, that's what I get for trying to do too much in my head. Negative 29. Now, that is the y value of our vertex. We plugged in a negative 6, and we got a negative 25. Negative 29. That means they are a ordered pair, or an ordered pair, I should say. All right. Now, even though we could do the rest of this without graphing, I like to sort of imagine what the graph's going to look like. So let's see. The a value is positive, which means it's going to be open up. So let's just do this right here. It's going to be open up like that. The vertex will be right there, and that's our point, negative 6, negative 29. Even if you don't write that down, visualizing that will help make the rest of the problem a little bit easier. Axis of symmetry, that's always x equals the x value of our vertex, so it's x equals negative 6. The maximum minimum value, let's take a look at our little mental picture right there. The vertex will be a minimum, since it's the smallest point on the bottom of that U, and the minimum value will be the negative 29, the y value of the vertex. Concavity, it's going to be concave up because it's open up. Remember, we got that from our a value being positive. Domain for any quadratic is all reals. And then the range, let's see, it's going to be all reals where y, let's think. It's got a minimum value, so that means the range values are going to start at negative 29 and go up from there. So it's y is greater than or equal to negative 29. All right, and those are the answers we get. All that information without even having to graph, except for that short little visualization of what it would look like. Let's take a look at our objective. Today we're going to do Chapter 4, Section 2, and after today's lesson we should be able to write quadratic equations in standard form. So today's objective is sort of the opposite of what we just did in the warm-up. In the warm-up, they gave us an equation, and we had to find all this information about it. What we're going to be doing in today's lesson is they're going to give us some information about the quadratic, and we're going to have to sort of supply the equation. We're going to have to come up with the equation based on what they gave us. Let's take a look at example 1. It says write a standard form equation for a quadratic that fulfills the following requirements. We've got vertex at 2, -3, and a y-intercept at 5. All right, now, at least how I would start with this, whenever they say write a standard form equation, I think, okay, well, what's my standard form look like for a quadratic? Well, that would be y equals ax squared plus bx plus c. That's the very first thing I'm going to write down, because that's going to give me sort of a formula, a format where we just have to plug in the missing numbers. So to end up with a quadratic equation, all we need is a number for a, b, and c. We just have to find 3 values, plug them in, and we'll be done. We'll have our whole standard form equation. Now, they've actually already given us one of these values, a, b, or c. Do you see which one they gave us? And this information, since they told us the y-intercept is at 5, if we remember from standard form, the y-intercept is always our c value. So that means right away I can rewrite this as, okay, y equals ax squared plus bx plus 5. So we're 1/3 of the way there right off the bat in our first step. Now, the only other piece of information they give us is this vertex. Now, if we were using vertex form, that would be our h and k value, but we're using standard form, so we don't have h or k anywhere in our formula. But even though, how do I want to say this? Even though we can't use h and k, we can still remember that this ordered pair is an x and a y. Now, this is a big skill we need to get better at as we grow in our algebra careers, or algebraic careers, I should say. Whenever we have an ordered pair, whenever we have a point, that is an x and a y value that go together, which means we can plug them into the equation we're working with. That's not, how do I want to say this? You don't always need to do that, but it's always an option. So from now on, anytime you see a point, you should think, okay, is there a place I can plug that in that would be helpful? And here, definitely. Instead of y, I can put -3 equals a times, let's see, x is 2, so a times 2 squared, plus b times x is still 2, plus 5. Now this is a lot better. I mean, up here we have 1, 2, 3, 4 different unknowns, y, a, b, and x. But once we plug in our x and y, we're down to just an a and b. Now that's not perfect, but it's easier to work with. So let's see what we can do here. Let's just simplify this out. This looks kind of messy. Let's leave -3 alone at first. A times 2 squared is 4, so it's 4a plus 2b plus 5. And the -3 and 5 are like terms. Let's combine them by using inverse operations. So that gives us -8 equals 4a plus 2b. So we were going pretty good there for a second, but we sort of hit a dead end here, because at this point, we have one equation with 2 variables. We have a and b, and hopefully we remember, anytime we have 2 variables, that's a clue that 2 equations would be helpful. So if we can go back to our given information and come up with a second equation that has a and b involved, then we'll be able to sort of get past this dead end we're at right now. So let's think back. Well, we're dealing with standard form, and as soon as we say standard form, you should think, oh, there's a formula I can use here. Besides the formula, which is standard form, there's a second formula, which we always start with standard form. Hopefully you remember from the warm-up, it's -b, let me scroll down a little bit. That'll probably be fine. -b over 2a. Let's separate this so we can keep track of what step is where. Now, -b over 2a, that does not look like an a. That's a little bit better, I guess. We have to know what this would give us. Let's think back to the warm-up. Well, in the warm-up, we use -b over 2 right here to get our -6, to get the x coordinate of the vertex, which means here, in example 1, this -b over 2a is going to equal whatever the x coordinate of the vertex is, and look at that. They give that to us. So -b over 2a is going to equal 2 in this case. That's the key step to this whole example, and really this whole video. Using -b over 2a and saying, okay, instead of plugging in a and b, because we don't know a and b here, we have to say, all right, even though we don't know a and b, we know that -b over 2a will give us the x coordinate of the vertex, so we can set it equal to the x coordinate of the vertex they gave us. We can set it equal to 2. Hopefully that makes sense. Now, I don't like the way this looks. I want to get one of my variables by itself, and the real thing that's getting in the way of that is the division. There is a shortcut here. I'm going to show you the long way first, then I'll go back and show you the shortcut, just so I don't lose anyone. To get rid of division, hopefully you remember, well, the inverse of division is multiplication. And anytime we're trying to undo division, we multiply by the denominator, what's in the bottom of the fraction. That's the only way you're going to cancel out division. So I see a 2a in the denominator, so let's multiply by 2a. And that leaves us with negative b equals 4a, which looks a lot better, but I want one of my variables to be completely isolated, completely alone. I don't like that negative there. So we've got two options. We can either multiply by -1 or divide by -1. It does not make a difference. And that's going to give us positive b equals -4a. Positive b equals -4a. Now, like I said, there is a shortcut to getting to this. Now that I think about it, I think it'll be better to show you the shortcut in the next example because I don't want to make this first example too confusing right off the bat. Now, how do I want to say this? Now that we have b equals -4a, we have two equations with the same two variables. Two equations with the unknowns b and a. So I can take this -4a and substitute it in for b because it equals b. And that's going to give us an equation with only one unknown. So let's do this in a different color to show that we're sort of combining the two equations now. So this new equation will be -8 equals 4a plus 2 times -4a. Just take the -4a, substitute it in for b. Now let's run through the algebra. Let's see, this would be -8 equals 4a minus 8a. That gives us -8 equals -4a when we combine, divide everything by -4. And we end up with 2 equals a. So we found our a value. Now to find b, we just plug in our a value. We plug in 2. So this equation, again, let's separate this so we can keep the two equations sort of separate, even though we're sort of plugging them in back and forth. We end up with b equals -4 times 2, which hopefully we can see is just -8. b equals -8. Now the trouble is we're not done yet, because remember, they asked us for an equation, so we have to take these values and plug them into standard form. So our final answer will be y equals a, which is 2, x squared, plus bx, which is -8x, because -8 is our b value, and c is what we found first. What was that? +5. Yeah, we can see right there, +5. So scroll down, +5. And that is our final answer. This isn't the only way to do this problem, but to me, this is the way that makes the most sense. And the reason why I like this method, as far as from the teacher's perspective, is that it forces you to remember the most important thing in this chapter, the -b/2a. The fact that that gives us the x coordinate of the vertex. So anytime we can use -b/2a, I like to do that to sort of show you how versatile this formula is and how it really helps us in a lot of different types of quadratic problems. Let's take a look at example 2. Same directions, we're going to write a standard form equation for a quadratic that fulfills the following requirements. They give us a vertex at 5, 7 and y-intercept at 16. Let's not waste any time, let's jump right in. Well, standard form, as soon as we see standard form, that means we got to start with standard form. So it's y equals ax squared plus bx plus c. Now, if you're pretty good at this, you might be able to skip that and say, well, wait a minute, we already know what c is. We can just say, okay, ax squared plus bx plus 16, because the y-intercept is always our c value. So, if you're on your game, you can skip that step and plug in 16 right off the bat. All right, so we use 16. Now we have to use the vertex. But remember, we cannot use it as h and k because we're not using vertex form today. We're using standard form. Even though, how do I want to say this? Even though we can't use h and k, we can still treat 5 and 7 like the x and y they are. Remember, that's a big skill. I know I'm repeating myself, but it's worth repeating. That's a big skill we need to be getting better at as we grow in our algebraic careers, our mathematical careers, as they say. Anytime you see a point, you got to think, oh, that's an x and y I can plug in. And here, we've got an equation we're trying to build up. So let's plug in x and y. Let's plug in that ordered pair. So let's see what we get. Instead of y, we can write 7 equals a times 5 squared plus b times 5 again, just plugging in x plus 16. If you're going to skip some of the simplifying, that's good. I'm just showing all my work. We get 7 equals 25a plus 5b plus 16. Take away 16 just to combine our like terms. That becomes -9 equals 25a plus 5b. And we hit that dead end. We can't move any further with this equation because there's one equation with two unknowns, a and b. So this is where that key step comes in of using negative b over 2a. And remembering that negative b over 2a is such a critical equation when we're using standard form because it represents the x coordinate of the vertex. If you remember the formula without remembering what it gives you, it's useless. Negative b over 2a gives us the x coordinate of the vertex. And even though we don't know b or a, that's what we're trying to find, we can still use this formula because we know what it's going to equal. Negative b over 2a equals the x coordinate of the vertex, which means for this problem, it will equal 5. So negative b over 2a equals 5. Now, in the last example, I promised a faster way to sort of get b by itself to isolate one of our variables, and that's what I'm going to do. Let me do this in a different color just so it stands out. I'm still going to get rid of the division. We're still going to multiply. And we're still going to multiply by 2a to cancel that out, but let's cancel out the negative at the same time. Because remember, a negative times a negative will be a positive. So if we multiply by negative 2a on both sides, where the 2a's will cancel out with the division, and the negatives will sort of cancel out and become a positive b. So that's how you can get b by itself in just one step. If that was confusing, you can still do it in 2 steps. Do whatever works best for you. And so b equals, let's see, 5 times negative 2a, that's negative 10a. And now we are no longer stuck. We no longer have a dead end here because we have a second equation with the same 2 unknowns, a and b. So we can substitute in. We can take this negative 10a and plug it in for b. And that's what we're going to do. Negative 9 equals 25a plus 5 times negative 10a. Now we just do a little simplifying to get a by itself, or a little solving, I should say. We get 25a minus 50a. Then we get negative 9 equals negative 25a. Divide by negative 25. And that comes out to positive 9 over 25 equals a. Kind of an ugly decimal, but we can deal with that. We can deal with that. All right, so we got, I forgot to color code that. Oh, well, that's what happens when we got a colorblind teacher. What can I say? Sometimes I forget to color code. So now we can take that a value and plug it back in. Let me take this equation and bring it down. Tell you what, let's just bring all this work and drag it down. Let's see if this will work nicely. Yeah, that wasn't too bad. Now it's a little easier to see it all on one screen. What were we doing? Right, we found a, so we can just take 9 over 25 and plug it in for a. Let's see what that gives us. We end up with b equals negative 10 times 9 over 25. So let's make that a negative 10 over 1, just in case that's helpful to anyone. And we can cross cancel here. The 10 and the 25, divide them both by 5. We get a 2 and a 5. So we get b equals, let's see, negative 2 times 9 is negative 18. Then multiply the denominators, and we get 5. Now for our final answer, we just plug it into standard form. Y equals 9/25 x squared, because that's our a value, minus 18 over 5 x plus, I've already forgotten what c was. What was it, 5? Oh, no, 16. I guess it was 5 last time. That's why I was double check. And that's our final answer. One more to go, and I'd like you to try this one completely on your own. So pause the video right here, give this one a shot, come back when you're ready to see if you got the answer correct. 3, 2, 1, let's go. So the quadratic function has a vertex at negative 6, negative 20, so that's obviously going to be really important. Let's copy that down here. So negative 6, 20, or excuse me, negative 20 is the vertex. And the quadratic function can be represented by the equation y equals ax squared plus bx minus 8. Again, I'm going to copy that down here. I always like to copy my important information because the paragraph sort of makes my eyes roll into the back of their heads. A list, I can sort of immediately see and think, okay, that's the important information. So we got to determine the value of a and b. So this is a little different. They're not asking us for a standard form equation. They're just asking us for a and b. So all we have to do is find a and b. So tell you what, to emphasize that, right here, I'm going to put find a and b. Find a and b. I'm going to put a star by that in case I forget what we have to find. That's a sort of a trick I developed in college. Like, okay, whatever they're telling you to find, I'm going to write that down and put a star by it. Especially if they're giving us a word problem like this, it's easy to do all this work and then forget what they told you to find. So that's why I like to put a star by that to focus myself on that. Okay, a lot of talking for me. Let's jump into the problem. Let's see. They actually already gave us the y-intercept in the equation as c, so that makes our life a little bit easier. We can just go straight to plugging in our x and y. You can plug in x and y. So that becomes negative 20 equals a times negative 6 squared plus b times negative 6 minus 8. And then we do our simplifying. Negative 20 equals 36a minus 6b minus 8. Got to make sure my 6's and b's look sort of at least a little bit different here. What can we do now? Oh, add 8. Combine our like terms. And we end up with negative 12 equals positive 30. Oh, no. Why am I trying to combine those? 36a, negative 6b. This is a dead end. We cannot combine anymore because we have two unknowns. We've got a and b. So this is where negative b over 2a comes in. Draw a line right there. Negative b over 2a. Hopefully at this point we know that always equals the x-coordinate of the vertex. So the x-coordinate is negative 6 right here. So that's what we set our negative b over 2a equal to, negative 6. Now we can use our inverse operations to get b by itself, multiply by a, need a little bit more space here. Multiply by a negative 2a. We can just use the shortcut to make this a little bit quicker. So that will cancel out the 2a's and the negative. We get b equals positive 12a. Now we're ready to substitute in. This equation turns into negative 12 equals 36a minus 6 times 12a. We can substitute in for b. And we just solve for a. Negative 12 equals 36a minus, let's see, 6 times 12 is 60, 72a. Scroll down a little bit. Negative 12 equals, combine our like terms, 36 minus 72 is negative 36a. Then divide by negative 36 to end up with, let's see, 12 is, well, it's going to be positive. 12 goes into both, so it's going to be 1 over 3. So we just get 1/3 equals a. That's our a value, which is actually our first answer, because all we need to do is find a and b. And to find b, we just take that 1/3 and plug it in up there. So that's going to become b equals 12 times our a value, which we just found out was 1/3. We end up with b equals 4, and that's our answer. So let's write this all together. So a equals 1/3, b equals 4, and we are done, because all the directions wanted us to do, if we scroll back up, we just had to find a and b. That's why I put that right there in case I forgot. Find a and b. So we're all done. A and b. All right. Here's your assignment for today. I want you to do page 208, numbers 49 through 52. Problems very similar to the 3 examples we did in this video. As always, if you have questions, let me know. Enjoy the rest of your day.